In this video, we'll consider 4 ideas and I leave 9 homeworks for problems of math counts and for school competition, sprint round, and also target round, and the last part is team round. Okay, and I leave homework from HMMT, Harvard, MIT Math Tournament, American Mathematics Competitions, Amy Sumac for Sumac, Stanford Summer Camp Promise, and there are around 40-50 important background ideas in each topic: combinatorics, algebra, number theory, geometry. If you want to learn them, feel free to send message to my WhatsApp number in the description comments. For each part, we will solve last problem, okay? And you can prepare for this exam and also other Olympiad math exams. So here I will tell you important idea casework, and I leave 3 homeworks here. If you want to know exact homeworks or what, as I said, feel free to send message to my WhatsApp number in the description comments. Last problem of this part, team round. I will tell you pi principle of inclusion and exclusion in this part, and also general form of pi. You can do it as homework. And as I said, if you want to solve more problem, want to prepare for any math exams, want to learn more background ideas, all important background ideas, you can send message to my WhatsApp number in the description comments. Okay. Okay, here math counts sprint round, problem 1 to 30. Let's move to last problem. It says what value of x yields the minimum value of the sum absolute value of x minus 2 to the 0 plus absolute value of x minus 2 to the 1 plus absolute value of x minus 2 squared plus absolute value of x minus 2 cubed plus 2 plus absolute value of x minus 2 to the third. So try this problem first on your own. Okay. Let me tell you one idea. drawing diagram here can be useful. Okay, in many other problems of AMC, Amy also this idea useful as homework 1. I know 2 problems of AMC, homework 1, homework 2. I research and tell you. And let me tell you, there are, if you want to know exact problems or what I research, feel free to send message to my WhatsApp number in the description. Commence homework 2, a problem from homework 3, a problem from Amy. Homework 4, a problem from PMO, Philippine Mathematical Olympiad, with drawing diagram. Here, let's see how we can draw it and how we can use it. Okay, let me open a new page. Okay, let me draw like this. 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7, 2 to the 8, 2 to the 9, 2 to the Okay, now if x is here, we consider the difference to all these parts, okay? So if x goes 1 unit to right, so 1 will be decreased from all of them. And because we want to have minimum, so it's better to move x to right. And also, if x is here, by the same thing, we can say it's better that x moves to left. Now, by this approach, try, for example, consider x equals 2 to the 0. Is it good that we move x to right or not? So, use this approach and see the answer is what. Try first on your own. Okay, let's move x, for example, 1 unit to the right. Because it is 1, it is 2, so if we move 1 unit to right, it goes to 2. Now, let's see what happens. For this part, we have plus 1, but for all these parts, we have minus 1. Because now x is 1 unit nearer to all these numbers. So it will be minus 9, minus 10 plus 1. Minus 9, so it is better. It will be smaller, so we move it. So now that you saw this approach, see, is it good that we move it to right or not? And it's good that eventually x reaches which number. Try this part first on your own. Okay, so now if we move these to right, for these two parts, we have +1, for the others -1. We have 9 -1s, 2 +1, so it's better to move it. By the same proof, it's good to move, keep moving up to 2 to the 5. When we reach here, so when we are in 2 to the 4, if we move, we have 1, 2, 3, 4, 5 +1, 1, 2, 3, 4, 5, 6 -1. So it's good to move. When we reach here, if we move it to right or left, it is back. It is. Let's check. If we move it here, 1, 2, 3, 4, 5, 5 negative ones, but 6 positive ones. So it's not good. So here it's not good to change. Also, if we consider the points, it's good to move to reach this special point P. Okay, so this point is good. Now we understand. Best answer is when x equals 2 to the 5. Okay, so we solved this problem of sprint parts. Now let's check the other parts. Okay, let's focus on this part. Target round. We have 8 problems. Let's work on last problem. This is let the try and be defined as a 3-digit integer for which any 2 digits of the integer ordered as they appear in the original integer form a 2-digit prime number. For example, 137 is prime because 13, 1, 3, 1, 7, 17, and 3, 7, 37 are all prime numbers. However, 211 is not a prime because 21 is not prime. Yes, 11 is prime, but 21 is not prime. What is the greatest prime? Okay. So when we want to solve this problem, one good idea is to use casework. Okay, so as idea 2, you can use casework, but from which part we should use casework? Most of the time, the priority is to start from the most restricted case. The most restricted case. Okay. And I've told you 4 homeworks, homework 5. We have a promise problem, promise summer camp, prestigious summer camp for Boston University. It has a problem ANGN related to divisors. It is related to casework, homework 6, last problem of SUMAC 2022, Q8. It is a casework problem. It's for Stanford summer camp. Homework 7, I can tell you one problem of HMMT, Harvard MIT Math Tournament 2023, that for that problem also you should use caseworks. Okay. If you want to know those problems are exactly what, feel free to send message to my WhatsApp number in the description comments. Now, here for using caseworks, consider the number is, for example, ABC. We draw these lines that it is not product of ABC. So A is C, for example, is 1's digit, 10's digit, and 100's digit. Now, it's good to focus on which of them, cases of what. We want to find greatest number. It's good to focus on A or B or C, on A. Because A is important for example, the number that is greater or not, and it's good to check from which A9, then for example A8, and keep writing like this, 7, and so on. So try to check this one first on your own. Okay, let's check, for example, if A is 9. So 90 what numbers? Because 9, then it will be 9BC. 9B and 9C should be prime numbers. 91 is not prime number because uh, it is multiple of 7 and 13. 92 even number. 93 multiple of 3. 94 even number. 95 multiple of 5. 96 even. 97 is a prime. 98 even, 99 multiple of 9, so only 97. So if we also write 977, we have to write this, but 77 is not prime. So you cannot create any three-digit number that satisfy the conditions of the problem and the hundredth digit equal to 9. Now let's check 8. If 8 was not possible, check 7. Try the rest on your own now that you've learned. Okay, if you check 8, 8BC, 81 not prime, 83 prime, 85, 87, 89 prime. Now we can create 833 or 899. Again, it will be 33 multiple or 99 multiple of 11, like 77. And if you write 839 or 893, both 39 and 93 are not prime. So for 8, it's not possible. For 7, 71 not prime, 73 not prime, 79 not prime. All numbers that starts with 7 and 7. Here, if we prefer to have 7 next digit 9. Okay, but then if you select 9 here, it's not good. If you select 3 here, not good. 91 also not good. So after 7 cannot be 9. If we select 3, 9 is not possible. 39 is not prime. 33 not prime, but 31 is prime. So the greatest number is 731. Okay, team round. We have 10 problems. Let's again try. Last problem here. It says how many of the first million positive integers share no common factors greater than 1 with 2020. Try this problem first on your own. Okay, for this problem first, we should find out that the factors of 2020 equals what? Okay, if we factorize 20, prime factorize 2020 for is 202 times 10. 202 is 2 times 101, and 10 is 2 times 5, and then it will be 2 squared times 5 times 101. Okay, now if a number, we want to check first 1 million positive integers, means 1, 2, 2, 1 million. Okay, if we check, we should here find the numbers that are not multiple of 2, not multiple of 5, not multiple of 101. Okay, so let's write it in a new page. Okay, if for example we consider A is multiples of 2 from 1 to 1 million, and here let me write like this. Okay, B multiples of 5 in this interval, C multiples of 101 in this interval. So the answer is 1 million or 10 to the 6 minus number of elements in A, or let me write like this, n of A union B union C. For this part, I should tell you idea 3. Idea 3 is what? Is pi. Is principle of inclusion and exclusion. Inclusion and exclusion. Okay. Now, for this part is what? For example, n of A union B equals n of A plus n of B minus n of A intersect B. Okay, we can check with Venn diagram. We can prove as homework, you can prove it. As homework 8. Prove it if you had question or wanted to learn more ideas, feel free. Send message to my WhatsApp number in the description comments. For this part, you can say n of A plus n of B plus n of C minus n of A intersect B minus n of A intersect C minus n of B intersect C plus n of A intersect B intersect C. Okay? And in general, again, as homework 9, prove this part. And homework, next homework is find this one is what? Proof. For general case, when we have case subsets, it has a formula and the proof is not hard. By binomial theorem and a lot of other ways, you can prove it. Okay. So, and one more thing. Here we want to find, for example, multiple of 2 between 1 from 1 to 1 million. Idea 4 is multiples of A in between which numbers 1 to n equals what? N over A floor of that. Okay. The proof is not hard because you say, okay, AK from 1 to n. So K and K is integer. Greater than or equal 1 over A and less than or equal n over A. Because K is integer, you can say it is at least 1 and at most floor of n over A. So the number of them is n over A. It was proved. Idea 4. Now, use pi and solve this problem. Find the answer. Try on your own. Okay, so let's calculate this part together. 10 to the 6 minus n of a. So let me write here 10 to the 6 minus n of a. We use this formula of pi. Okay. Minus number of a multiples of 2. Now we use idea of 4 n over a. So 10 over 6 over 2 is 500,000 minus 10 over 6 over 5 is 200,000 minus 10 over 6. Let me write 10 over 6 over 101 plus a intersect b. 10 over 6 over 10. 2 times 5 is 10 to the 5 plus 2 and 101, it will be 10 to the 6 over 202 plus b and c 10 to the 6 over 100, 505 minus 10 to the 6 minus a intersect b intersect c over 10, 10. Now we should calculate this part. Calculate this first on your own. Okay, let's calculate. 10 to the 6 minus here 500,000, 200,000 minus 700,000, and it will be 300,000 minus. Next one is what? Is 10 to the 6 over 101. If we calculate, it will be minus 9,900 plus 100,000. Here we can change it to 400,000. And then plus 10 to the 6, next one, over 202. So this one will be 4950. Next one is this number over 505, which is 1980. And last one is 10 to the 6 over 1010, which is 990. And if we calculate, let's see. Here these numbers, this minus this is 0, 18 minus 9 is 9, 8, 18 minus 9 is 9. This number is 0, 14, we have 1, 10, 19, we have 5. And if we calculate this minus this, we say minus 0 minus 0, 0, 10 minus 4, 6, 18 minus 9, 9, 8 minus 5, 3. And it will be this minus this. So the last answer will be 0 minus 0, 0. 10 minus 6 is 4. 9 minus 9, 0. 9 minus 3, 6. So, okay, 4 digits. 1, 2, 3, 4. And next one is 9. Next one is 3. Okay, so the answer is this. And how many ideas did we have? 4 ideas. 9 homeworks. Okay, if you want to learn more ideas, more background ideas, and want to solve more related problems from different prestigious math exam summer camps from USA, UK, feel free to send message to my WhatsApp number in the description and comments. Also, as I said, there are around 40, 50 important formulas and ideas in each topic, combinatorics, algebra, number theory, and geometry. If you want to learn them, feel free to send message to my WhatsApp number in the description and comments. Okay, thanks for watching this video. Bye.